क्वेश्चन अच्छा क्वेश्चन पेपर 4-3 ठीक है. So I guess अच्छा I guess this one is from वो enthalpy of solution ठीक है. तो question ये कि all this data is given. He's saying complete the energy cycle involving the enthalpy change of solution. तो enthalpy change ये छोटा सा टॉपिक था energetics ठीक है. We did this earlier. So enthalpy change of solution उस पे क्या होता था कि 1 mole of a substance would dissolve. तो enthalpy change of solution was कि अगर if you have KCl solid then it will dissolve and it will become KCl aqueous. ठीक है. तो KCl aqueous का मतलब है कि it's going to become K+1 aqueous. मतलब मैंने randomly I have chosen the left box ठीक है. Plus it will become Cl-1 aqueous. Ionic compound जब भी dissolve होता है it dissociates ठीक है. So you've got this going on. KCl solid turning into KCl. It's turning into KCl aqueous. This is your enthalpy change of. By definition, enthalpy change of solution जो था वो ये था. तो इसका lattice energy of potassium chloride. Lattice energy was कि when gaseous ions would combine to form 1 mole of solid ionic lattice. ठीक है. तो ये जो था ना that was your lattice energy ठीक है. delta H lattice energy कि gaseous ions combining to form KCl solid. And enthalpy of hydration. Hydration क्या होता था? Enthalpy change of hydration was either इसमें ये सही definitions जो है ना ये यहाँ पे notes में थी. इक्विलिब्रियम ने start करना है energetics ठीक है. तो all these definitions were ये A2 chemical energetics, atomization, electron affinity, lattice energy ठीक है. Lattice energy was that gaseous ions would combine to form 1 mole of ionic lattice ठीक है. That was what lattice energy was. Bond formation होती थी, ionic bond formation. Gaseous ions they attract each other, they form ionic bonds, they form this solid ionic lattice. So it was always exothermic ठीक है. और फिर इसी तरह you had वो किधर गया आपका just 1 second, it's not. अच्छा उसी तरह फिर you had definition enthalpy of solution. Enthalpy of solution was that you had an ionic solid, it would dissolve and it would form, and it wasn't necessarily an ionic solid, it could be any solid. Or enthalpy change of hydration was that you had gaseous ions and they would combine with water and they would become hydrated ions. They would be surrounded by water molecules. ठीक है. तो यहाँ पे gaseous ions, they become aqueous ions. They become surrounded by water molecules. So that's your enthalpy change of hydration. तो ये आपका ना that's your delta H hydration. So I guess what 2 marks was for this. The next part is calculate the enthalpy change of hydration of magnesium ions. Show your working. ठीक है. So you've got a cycle now. इधर से data pick करो and plug it in. ठीक है. So all that is all you got to do. तो क्या क्या data है? What's the lattice energy that's being given होगी यहाँ पे KCl. It's over here. That's -7. That's -701. ठीक है. This one is -70. अच्छा enthalpy of solution of KCl की ऊपर that's given. That's +15. So I guess that's also given. अच्छा फिर अच्छा सॉरी उसने ना ये तो मैंने KCl के लिए ड्रॉ किया. He's asking for magnesium ions. तो I'm going to draw a very similar cycle for based on the data. ये गलत है ठीक है. This is also fine लेकिन इसके अंदर ना साइकिल के अंदर everything is already given. Enthalpy of hydration of K+1 that's -322. and enthalpy of hydration of Cl ions, that's minus 364. So there's no information that's hidden. Everything is known, so that cycle is already. He's asking for magnesium, so I'm going to do it for MgCl2, the same cycle for MgCl2. So we can start with enthalpy of solution. क्या था enthalpy of solution? It's MgCl2 solid, which is going to dissolve. ये ऊपर वाली cycle ही draw करो. So it will become what? It will become magnesium ions aqueous, and it will become Cl ions aqueous. So that's delta H solution. And this value is given over here. That's minus 155. So enthalpy of solution हो गया lattice energy. What is lattice energy? You form an ionic lattice from what? From gaseous ions. So the gaseous ions in this case are going to be Mg2 plus gas plus 2Cl minus 1, also gas. So the gaseous ions will combine to form MgCl2. So that's lattice energy. And if that's lattice energy, that value is also quoted over here. किधर है? MgCl2, that's minus 2493. So this one is minus 24. Or finally, pair hydration. Hydration is this thing, gaseous ions turning into aqueous ions. So the Cl line hydration is already given. That's यहाँ पे given. The enthalpy of hydration of Cl lines, that's minus 364. So that one is already provided. So minus 364 times 2, because you got 2 Cl ions. Enthalpy of hydration of magnesium ions, that is not given. So वो क्या होगी? That's going to be X. वो नहीं पता. So the cycle के अंदर ना, there's one thing missing. So what is the Hess law? Hess law states that one path is equal to the other path. So that's your one path. That's your other path. जिसका मतलब है minus 155 is basically equal to what? इसको उल्टा करो, that's plus 2493. And plus X, so you're going in the right direction, plus X and minus 364 times 2. और इसको solve करना. So solve for X, find out what X is. So it's going to be minus 155. ये कोई solve करके बता दे. Minus 2493. Then plus this 364 times 2. क्या value आ रही है?
So, negative 1920.
1920, right?
Yes.
So ठीक है, hopefully that would be the correct one. You could check कर लेना वैसे इसका, ठीक है? Remember, energetics question में you can get a lot of mistakes, like mathematical mistakes, just simple careless mistakes, ठीक है? While solving this, ठीक है? So there's a pretty bright chance that this might be wrong, ठीक है? Not because the method is wrong, just silly mistakes, ठीक है? As I explain, the reason why the lattice energy of MgCl2 is more exothermic than KCl. तो क्या reason है कि more exothermic? When you form a stronger lattice, more energy is released, right? So if forming this lattice releases more energy, तो इसका मतलब है it is a stronger lattice, ठीक है? It's a stronger ionic lattice. तो क्या reason होगी? Why is it a stronger ionic lattice? को याद है कि why would?
Charge on ions is greater.
हाँ ठीक है. So K का क्या charge है? +1 है ना? So obviously the attraction is going to be lesser. Mg का जो charge है, that's +2. So obviously the attraction is going to be a lot stronger, right? और तो so it's basically mg is the factor, ठीक है, मतलब cl तो दोनों में common है, so that's not a factor. So mg has a greater charge, so there's more attraction. दूसरा क्या factor होता था apart from charge?
Ionic radius.
ठीक है, छोटा n जो होगा वो करीब करीब होंगे तो stronger attraction, right? So mg just has 10 electrons, mg ions, ठीक है, 28. k जो है ना, that's much bigger in size, वो 288 है, ठीक है, that means there's an extra, तो दोनों लिखोगे, mg has a greater charge, yeah, mg ion has greater charge density compared to k plus 1 because it's got a greater charge and it's got a smaller ionic radius. So hence the ionic bonds formed are much stronger, ठीक है, बस ये बताना है. Define the following terms. Enthalpy change of atomization, ये इधर कहीं डिफाइंड थी, अभी इधर आया था बीच में ना, बॉर्डे साइकिल से पहले था, I guess. Enthalpy of atomization was when you form one mole of gaseous atoms from what? From the element. तो energy needed क्योंकि you're breaking bonds. Atoms बनाने के लिए you would have to break bonds in the element. ठीक है, so it's endothermic. So it's energy needed when one mole of gaseous atoms are formed from its elements in standard state measured under standard conditions. ठीक है, one mole of gaseous atoms from its elements. ठीक है. First electron affinity. It's the energy that is released when an atom, gaseous atom, gains 1 mole of gaseous atom gains 1 mole of electrons. ठीक है, मतलब by equation जो definition है, that's कि उसने एक इलेक्ट्रॉन, it has gained 1 electron. अच्छा, what is meant by entropy? So it's a measure of disorder of a system. ठीक है, that is literally what entropy is. Explain the solubility of potassium chloride by reference to change in entropy. So explain the solubility of देखो वो कह रहा है by reference to change in entropy. KCl solid है, dissolve होगा तो it will become K plus 1 aqueous Cl minus 1 aqueous. ठीक है, तो पहले तो बताओ कि entropy disorder, is it increasing or decreasing?
Increasing.
ठीक है, so the ionic lattice, ठीक है, it's breaking up, it dissociates into aqueous ions. ठीक है, so the number of particles increase, you get more disorder. So that means delta S is positive. बढ़ रहा है, ठीक है, ज्यादा हो रहा है, delta S is positive. I think 1 mark के लिए that's about it. And use Gibbs equation in your answer to predict whether potassium chloride is more soluble in water at 20 or at 80. Explain your answer. तो 20 पे ज्यादा soluble है. Gibbs free energy क्या होती थी? कि there was a thing called delta G, which was the overall intro वो था use energy available for useful work. ठीक है, the idea was कि when a system is undergoing a process, it releases heat energy and it releases energy in terms of entropy change. यानी इसको अगर रिवाइज करें ना क्विकली की तरह, एंट्रोपी ठीक है, ये अच्छा, ये this was what entropy, this is what we studied in entropy, that when a system works, it produces heat, but at the same time it produces work that is due to disorder. ठीक है, उसकी explanation मैंने यहाँ पे कहीं दी थी कि this one, I told you that when you burn petrol, what happens is that disorder gets created. ठीक है, when you burn petrol, तो आपका एक molecule जो होता है ना, that turns into tiny molecules. So the number of particles they increase. So one molecule all of a sudden they turn into 17 molecules. So all of a sudden this one molecule, it breaks up into 17 different carbon dioxide water molecules. and a lot of disorder gets created. A lot of particles get produced, and when disorder gets created, that disorder is going to push the piston upwards. The work gets produced. So जब भी disorder gets created, work gets produced. So a system produces work not only when it releases energy in terms of heat, but it produces a lot more work when it produces disorder. ठीक है? तो मैंने explain किया था कि if you burn a match, the heat energy gets produced, but you don't. एक second. अच्छा, so मैंने explain किया था कि when you burn a match, तो it produces heat energy. फिर हैंग हो गया. अच्छा, मैंने explain किया था कि when you burn a match, it produces heat energy, right? But it doesn't produce a lot of disorder, right? So it doesn't produce a lot of work. लेकिन जब आप कोई explosive firecracker burn करते हो, it doesn't produce a lot of heat, but it produces a lot of work that is due to disorder because it disintegrates into a lot of tiny particles. It creates a lot of disorder because the number of particles increase. ठीक है, जिस तरह वो कार इंजन में हो रहा था. And that work done by definition due to disorder is the entropy change multiplied by temperature. ठीक है, so it's delta H minus T delta S. Delta G is the overall energy that is available to a system. And if this energy is exothermic, that means the system has sufficient energy. It doesn't need energy from outside, and it will do everything on its own. And if delta G is positive, that means the system does not have enough energy and it needs energy from outside. तो यहाँ पे हम वो check करेंगे कि what's going to happen over here. So delta S, we already know कि when KCl dissolves, disorder gets created. A disorder is produced. तो इसका मतलब delta S is positive. ठीक है, ये यहाँ पे ना we had already figured out कि there is disorder being created. तो इसका मतलब है ये जो expression है इसका ये वाला part that is actually negative because it's got a negative sign in front of it. For enthalpy change, I don't know what the enthalpy change is for KCl dissolving, but it was given in the ये पीछे table में given था. KCl dissolving is slightly endothermic, very slightly endothermic, positive है, ठीक है, it's over here plus 15. So this one is plus 15. Yeah, बल्कि let's just call it positive. अच्छा, अब issue ये कि one of the terms is positive, the other one is actually negative, right? So what would be delta G, especially at a higher temperature? Just 1 second, hang हो गया. अच्छा, higher temperature होगा तो you take a bigger T, that means the negative part would be large. And if the negative part is large, that means तो अगर negative term large होगी, so delta G would also come out to be, it will come out to be negative. That means the reaction is going to be more feasible or more spontaneous. ये ठीक है, ये याद है?
Yes, sir.
ठीक है, तो overall delta G, ठीक है, bigger T, that means this term over here would be a lot more negative, and so that will make delta G more negative. And delta G more negative means that the system is exothermic, it will produce work, and if it produces work, it's going to be more spontaneous, ठीक है? तो यही आपने explain करना है, ठीक है? अच्छा, homogeneous heterogeneous catalyst, homogeneous same phase, heterogeneous is a different phase, ठीक है। ये वो यहाँ पे ना वो कह रहा है कि ये भी हमने किया भी था, तो वो एक्सप्लेन कर रहा है कि इस सेइंग के अच्छा ऑर्डर का क्वेश्चन आ गया। वही सेइंग दैट write to equation to show how the reaction is catalyzed by Fe2 plus, ठीक है। तो we had actually done this previously, तो एक दफा फिर go through कर लेते हैं। This is one example of heterogeneous catalyst that it has to be remembered. तो इसमें था कि you had this reaction going on, but two negative ions, they repel each other, so which is why they're not going to react with each other, ठीक है। तो ये स्पेसिफिक एग्जांपल यहाँ पे बल्कि लिखा हुआ था, यहाँ पे मैंने किधर वो इलेक्ट्रोकेमिस्ट्री नहीं, किस में लिखा था मैंने, आई गेस इसके इलेक्ट्रोकेमिस्ट्री के एंड पे था बिल्कुल, या शायद उसमें था।
So it might be in kinetics.
ठीक है। ये वाला ना, ठीक है। तो homogeneous catalyst का this was this example that you had to remember कि you had higher potential gains electrons, lower potential loses electrons. You get this equation. It's a very feasible reaction theoretically, but no reaction. Why? Because both reactants are negatively charged and they repel each other. So this will not react with this one. So what happens is, okay, the first equation is, even though it on paper it's feasible, but it won't happen. So this and this are not going to react together. ठीक है, तो और remember this कि a reaction can have high activation energy for, I mean, for any random reason. ठीक है, there could be, मतलब it's not, I mean, we know कि some reactions have very high activation energy. Like every reaction has its own reasons why the activation energy is high. This reaction की activation energy is high because both of them are negatively charged. अच्छा, अब यहाँ पे ये कि you got so you've got S28 and SO4 minus 2 and I minus 1. These two are not going to react with each other. ठीक है, we've done that. So what you do is you add iron ions. तो ये जो iron ions वाली equation है ना, when you compare it with the first reaction, the first one, this is the lower potential, so it loses electrons, ये backward चली जाती है, and that is the higher potential, it gains electrons, and you get this overall equation. Then the same iron ions go and they react with iodine. With iodine is the lower potential, so it loses electrons, and iron ions are the higher potential, so they end up gaining electrons. And you get this equation when you combine the two equations. और जब आप इन दोनों equations को ना, when you sort of see them together, you notice that Fe2 plus turns to Fe3 plus in the first reaction, and then the same Fe3 plus turns back into Fe2 plus. So that means they remain unchanged. Nothing happens overall to the iron ions. But you get both of your products. You get SO4 minus 2. You also get iodine as the products. You get both products, while the iron ions, they remain completely unchanged, and the reaction is much faster. क्यों? क्योंकि they are oppositely charged ions. ठीक है, तो ये खैर हमने पूरा डिस्कस किया था उस दिन. But remember, this specific example has to be, I mean, you'll probably get a 3-4 mark question on this, but this specific example has to be remembered. And I guess ये हमने शायद क्या था, लेकिन कर लेते हैं. Everything is given in this question. He has already told you कि it's second order with respect to nitrogen monoxide. So rate is equal to K. NO के respect से it's second order, right? And it's first order with respect to oxygen. So oxygen के respect से it's first order, ठीक है? So that's it. And you have to find the rate of reaction. So you can find the rate using this equation. K is already given. That's 8.6 times 10 power minus 10 to the power 6. और into NO is 7.2 times 10 power minus 4, and that's order 2, so that's squared. And oxygen 1.9 times 10 power minus 3. वो पावर 1 है, तो उससे आप बस क्या करोगे, रेट, यू विल फाइंड द रेट, ठीक है। अच्छा, फिर इधर वो कह रहे हैं कि the reaction has a constant half-life, so why does it have a constant half-life? Because it's a first order. I mean, the equation given है ना, it will follow first order reaction kinetics. मतलब लिखा हुआ है it's first order, ठीक है, directly proportional. Use this information, the question should, to show that the half-life of this reaction is, तो ये जो भी reaction है, he's saying कि, or the rate equation is given. He's saying use this information in the question to show that the half-life of this reaction is 2.7. ये हमने वो कहा था कि K is basically what? 0.693. First order reaction के लिए ना, there's this relationship के the half-life and the rate constant, they have a relationship which is this. So you can, your K is given, using that you can figure out the half-life. तो K की जगह ये put करो तो you'll find this. और अच्छा, ये मुझे कोई कैन समझ, अच्छा हाफ लाइफ तो उसने खैर बता भी दी है।
Yes, sir.
यही
Next
है,
question.
but you're getting the same answer, right?
Yes, same, sir.
अच्छा, now the other thing is कि part 3 जो है, he's saying that there's 8 times 10 power minus 6 moles of this thing, मतलब ये जो चीज है, it's added to 100 cm³ of water. Can you find the concentration of this thing? Concentration क्या होती है? Moles over volume, right? So there's 8 into 10 power minus 6 moles in what volume? Volume कितना है? 100 cm³. 100 cm³ is 0.1 dm³, right? तो ये क्या है? Is that 8 times 10 power minus 5?
Yes, sir.
अच्छा, remember ये rate equation does not take moles, it takes concentration, ठीक है? So मतलब कुछ लोग गलत ये कर देंगे, वो moles directly put कर देंगे, ठीक है? Remember the rate equation deals in concentration, so it's 8 times 10 power minus 5 mole per dm³, right? So that's your starting concentration, right? Reaction start where. Now we're saying calculate the time taken for the concentration to decrease to 2.5 times 10 power minus 6. So what is the amount of time for the concentration to decrease to this amount? अब याद रखना कि it's a first order reaction, right? It's a first order reaction, so that means the half-life is constant. तो अब start कर लो कि how many half-lives is this? You start at this point and you have to end up over here. So how many times would you have to halve the concentrations? But the first half-life क्या होगी? That's the first half-life, 4 times 10 power minus 5. मतलब कितना टाइम लगा? That's 2.77 times 10 power 4 seconds, ठीक है? That's the first half-life. Then the concentration decreases by another half. So it will become what, 2 times 10 power minus 5, right? अच्छा, उसके बाद it 2.5 times और दफा. Then it will become half again. So it's going to become 1 times 10 power minus 5 mole per dm³. 3 half-lives हो गए हैं. Then it will become half again. What's half of that? That's 0.5 times 10 power minus 5. या फिर आप इसको कह लो, it's going to be 5 times 10 power minus 6. Calculator पे इसका half करो ना, this is what you're going to get. and then you एक और दफा half करोगे ना, तो it's going to become 2.5 times 10 power minus 6. So how many half lives? That's like 1, 2, 3, 4, 5, 5 half lives. Is this clear? ये clear है?
Yes, sir.
Yes, sir.
तो वो हाफ लाइफ की वैल्यू उससे दी हुई है, दैट्स, तो इसको 5 से मल्टीप्लाई कर लो, ठीक है. सो दिस इज द टाइम दैट इज रिक्वायर्ड, ठीक है. और ये याद रखना कि इस सब में ना, इट्स यू बेसिकली डीलिंग विद कंसंट्रेशन, नॉट मोल्स, ठीक है. सो यहाँ पे उसने मोल्स जो दिए थे ना, वो कंफ्यूज करने के लिए दिए थे. मतलब इफ पीपल स्टार्टेड थिंकिंग अबाउट मोल्स, तो um, ये जो रेट में ना, you're actually dealing with concentration, you're not dealing with moles. अच्छा, डिस्क्राइब स्टैंडर्ड कंडीशंस क्या होती थी हाफ सेल के अंदर? कि बस solution concentration क्या होगी? That's going to be 1 mole per dm cube. And if there's a gas, then it's going to be at 1 atmosphere pressure. Or temperature would be 298 kelvins, ठीक है. तो वो कह रहे हैं SN4 plus SN2 plus का ना make an electrode. तो that electrode would, उसके अंदर ना SN2 plus and SN4 plus would both be part of the solution. और दोनों का लिख देना कि they are 1 mole per dm cube. And you'll add a platinum electrode. तो platinum electrode would be added. और उसका क्या पूरा डायग्राम ड्रॉ करो. सो यू हैव टू ड्रॉ द, किसके साथ कंपेयर करते थे? whenever you wanted to measure the potential of a cell, the standard potential of a cell, you'll measure it with a hydrogen electrode. तो you'll always measure it with a hydrogen electrode. तो यहाँ पे H+1 aqueous होगा, and there's going to be H2 gas. फिर क्या करना है? दोनों को कनेक्ट कर देना है. And there's going to be a salt bridge that's going to be added, ठीक है. That's your entire diagram, ठीक है. और label कर दो everything. Gas jar, platinum electrode, voltmeter, salt bridge, ठीक है. Write that down. चलो ठीक है, फिर मंडे से ना we'll start with the physical में एक ही रह गया. We'll start with that one, ठीक है. तो मंडे को कंटिन्यू करते हैं, ठीक है. चले, ओके, टेक केयर, अल्लाह हाफिज.
Thank you, sir.